All right. Good afternoon, good morning, good evening, whatever the time may be. Welcome to 6.2 Circular Motion. Hey, look, he's just going in circles. All right. First thing, let's review force and velocity. So force equals mass times acceleration, and acceleration is change in velocity over time. So anything that changes velocity needs a force. If it's turning, if it's going up, down, whatever, we need a force. So, three ways you change our velocity. Speed up, slow down, or turn. A force is needed, required for any of these changes. So in order for something to change what it's doing, a force needs to be applied. That is Newton's first law, the law of inertia. Uh, so far, we've pretty much looked at examples of things speeding up or slowing down. Now we're going to deal with things changing in direction, mainly in a circular way. So let's go over a couple key terms here. So rotate. Object is rotating if it's spinning in place. The object itself is spinning. There's not something on the object spinning. Revolving is when something is moving in a circular path. So this is an object spinning. This is a dog revolving around a particular point. So examples, compact disc, merry-go-round, revolving door. I know that seems a lot weird because it's, says revolving right in it. But a car on a circular track is revolving, kid on a merry-go-round is revolving, the person using the revolving door is going to revolve. The door itself is not revolving. The door itself is just spinning. All right, period. This is the amount of time it takes per spin, or to make one complete revolution or rotation. Frequency, on the other hand, is how many spins per second, or spins per minute, or per hour, whatever, just spins per given amount of time. Basic circle stuff, because this all involves things moving in circles, so let's look at some circle stuff. Circumference, that's this blue area right here, and that's the distance around the circle. Diameter, that is a point on the circle through another point, and it has to travel through the center. In other words, it makes the circle in half. That is that diameter. That's that kind of light green, mint, whatever color you want to call it, that cuts across. The radius is a point from the center to any point on the circle, so a quarter of the circle. Then anything that is traveling around the circumference is tangent. So this is indicating you can go counterclockwise or clockwise. All right, as far as formulas go, circumference is pi times the diameter, or 2 pi r. Diameter is twice the radius, and the radius is half of the diameter. Tangent. When we're dealing with this, we're dealing with objects that are traveling tangent to the circle. So the velocity in which it's moving is tangential velocity. Velocity itself is change in displacement, and if you're going around a circle and you're doing a full 360, then you really haven't changed your position. But you have changed it in response to the circle itself. So that's what we're looking at. That's the velocity we're referring to. Define that. What we're going to do is take our circumference and divide it by our period. Remember that the capital T is period. That is not just time. It is time per spin, or rotation, or revolution, or orbit. All fun things. Circular acceleration or centripetal acceleration is our velocity squared divided by r. All right, so let's go ahead and give this a shot here. What is the period of this object? So let's see, period is time per spin. So 3 divided by 15 should give us 0.2 seconds per spin. That's the period. That is our capital T. What is its frequency? So that's the inverse of period, or how many spins per given amount of time. This has a funky looking F for frequency. How many times will it spin in 12 seconds? All right, so 12 seconds. We're going to spin 5 times in 1 second. So 5 times 12 equals 60. I guess I should write that down. So just saying that. There we go. All right, how long will it take to spin 89 times? So technically, I should point out there's 2 ways that you can do either of these. So we have the frequency here. So we can do is take the amount of times, 89, and we could multiply that by 0.2, or we can take our 89 and divide it by 5. And that'll give us our how long it's going to take to spin 89 times. Yay! How much is its velocity? All right, so velocity equals 2 pi r divided by our period. Our period over here is 0.2, so 2 pi times our radius, which is 0.12, divided by our 0.2 over here. I took 0.12 instead of 0.24 because it's the radius. If you want to use the 0.24, then you can just do pi times the diameter. That also is the same thing. And you should get 3.77. Next, what is the acceleration? Acceleration is just v squared divided by our radius. So 3.77 squared divided by 0.12. And you should get 118.44 meters per second squared. All right, that is 6.2. Hope you enjoyed Circular Motion Basics. I'll see you next time.